Okay, we have 9.8 using sum and difference formulas on page 520 through 522 in your textbook. We have the sum and difference formulas, sum meaning addition, so we have sine, cosine, and tangent sum formulas, and we have sine, cosine, and tangent difference formulas, difference meaning subtraction. So they're really similar, and you can always refer right here as we're working through these. But I'd practice them to get to know them a little bit. Alright, so here we go. Concept 1, evaluating trig expression. Find the exact value of a sine 15 degrees. Well, a sine 15 degrees is not here on your unit circle, so I'm going to need to create it and use one of the sum or difference formulas. So here we go. A of sine of 15 degrees is equivalent to sine of 60 degrees minus 45 degrees. And now 60 degrees and 45 degrees are both on the unit circle, so that's going to help me find the values. So now if I take this right here and I go ahead and apply it to that sum difference formula, I get sine of 60 degrees cosine of 45 degrees minus cosine of 60 degrees sine of 45 degrees. I'm just using this right here. This is the formula. Just applying it here. And now what is sine of 60 degrees? Well, sine of 60 degrees is the y value, so it's root 3 over 2. Cosine 45 degrees is the x value, right there, 45 degrees, root 2 over 2. Minus cosine 60 degrees, cosine would be the x value right there, 60 degrees, which is 1/2. And sine of 45 degrees, the y value right there, root 2 over 2. Okay, so now I can go ahead and substitute those values in, and then I'm just going to multiply. So root 3 times root 2 is root 6. 2 times 2 is 4. Again, with fractions, you just multiply across. Minus 1 times root 2 is root 2. 2 times 2 is 4. And then, since I have common denominators, I can go ahead and combine the numerators, but it's still root 6 minus root 2 all over 4, and that is equivalent to sine of 15 degrees right there. Again, I cannot combine those. Those are not like terms. It would have to be like 2 root 5 plus 6 root 5, giving me 8 root 5, and that's not happening there. So, anyway, there is that first one, sine of 15 degrees. I'm going to go on to that second one, tangent of 7 pi over 12. Alright, again, 7 pi over 12 is not on the unit circle, so what I'm going to do is create it. And what I can recognize right here is I have pi over 3 and pi over 4. And if I multiply this one, 4 to both top and bottom, I get 4 pi over 12. And if I multiply 3 to both top and bottom here, I get 3 pi over 12. And then I have common denominators of 12. I can add the 4 pi and 3 pi to get the 7 pi. So I am going to go ahead and make this tangent of pi over 3 plus pi over 4. Then I'm going to go ahead and apply the tangent sum formula right here. So I'll leave it right there. Okay, so here we go. This is equivalent to tangent of pi over 3 plus tangent of pi over 4, all divided by 1 minus tangent of pi over 3 times tangent of pi over 4. Okay, now I'm just going to do a side note here. Well, what is tangent of pi pi over 3 equivalent to? Well, I look at the unit circle, and all I have for pi over 3 is sine and cosine. But we know that tangent is sine theta over cosine theta, so I can make it root 3 over 2 divided by 1/2. And I'll do copy that flip. Root 3 over 2 times 2 over 1. Cross cancel. And I get just root 3. And if I go here to tangent of pi over 4, well, pi over 4 right here, root 2 over 2 divided by root 2 over 2. Equals 1. Anything divided by itself is just 1. So there we go. So now all I'm going to do is substitute this in. Okay, so now I have tangent of pi over 3, which is just root 3, plus tangent of pi over 4, which is 1, all over 1 minus tangent of pi over 3, which again we got pi over 3, and times tangent of pi over 4, which is just 1. And I'll simplify. Root 3 plus 1 over 1 minus root 3. And now I have this radical in the denominator, and I can't have that, right? So I got to simplify that radical out of there. So what I'm going to do is multiply by the conjugate, 1 plus root 3, both top and bottom there. On the top, I'm just going to go ahead and FOIL. Root 3 times 1 is root 3. Root 3 times root 3 is 3. 1 times 1 is 1. 1 times root 3 is root 3. On the bottom, I got the exact same terms but a different sign in the middle, right? Gives us the shortcut of just multiplying the first and last terms. 1 times 1 is 1. Negative root 3 times positive root 3 is negative 3. Combine like terms on top. 3 and 1 is 4, plus root 3 and root 3 is 2 root 3. All over. 1 minus 3 is negative 2. And I'm going to continue to simplify here, but I can't simplify a binomial with a monomial, so I'm going to go ahead and factor out that greatest common factor of 2. And I am left with 2 plus root 3 all over negative 2. And then I can simplify that 2 and that 2. And now really I just get the opposite of this negative 1 distributed in there. And that gives me negative 2 minus root 3. And that is equivalent to tan of 7 pi over 12. Okay, if you could, go ahead and flip it up and give it a try. Pause at this point. I'm going to go ahead and show the answer. Alright, here are the answers to number 2. Give it a quick check. There you go. Alright, now I'm going to go ahead and start number 3. So pause it if you need that longer. Alright, concept 2, using different formulas. We have cosine of A minus B. That cosine of A equals negative 4/5, with that pi is less than A, which is less than 3 pi over 2, which really is a range that's telling me we are talking about quadrant 3. And we have sine B equals 5/13 with 0 is less than B, which is less than pi over 2, which tells me again we are talking about a quadrant, and this is quadrant 1. Okay, let's start with quadrant 3, the A, which means if I'm going to make this a triangle, right, I'm going to go left and then down from that origin, and here's my A, and then cosine's giving me my adjacent over hypotenuse, so it's negative 4 left, my hypotenuse is 5, I do need this side opposite, and I can use Pythagorean theorem, but this happens to be a Pythagorean triple, it's a 3, 4, 5 Pythagorean triple, and since I'm going down, right, that should be negative 3, so there's the A triangle. Can do the same thing with the B. here. So I have a B triangle. This one's in quadrant 1, so I'm going right and then up. Alright, so there's angle B. And if I take that, my opposite side is 5. My hypotenuse is 13. I need the adjacent. This one's also a Pythagorean triple. It's a 5, 12, 13 Pythagorean triple. So now I have all the sides there. And why I did that is because if I have cosine of A minus B, this is equivalent to cosine A cosine B plus sine A sine B. And if I look, right, I had cosine A, but I need cosine B, and I was given sine B, so I had to find it. And now I have it with this triangle right here. So I'm just going to substitute everything in. Cosine A was given to me at -4/5. Cosine B, now I can find it's adjacent over hypotenuse, so that is 12/13. Plus, right here, sine A, not given to me right here, I go the opposite, so it's -3/5. And cosine B given to me right there at 5/13, which I can always use a triangle as well. From there, I am just going to go ahead and multiply these two fractions. Just multiply across. -4 times 12 is -48. 5 times 13 is 65. Plus -3 times 5 is -15. 3 times 13 is 65. Now I have like bases, right, or common denominators. So I'm going to go ahead and combine the numerators, and I get -63/65. And there we go. Okay, guys, give number 4 a try. I'm going to go ahead and show that answer. So pause, take your time, work through it. And here you go. Here's the answer. Okay. Next page, number 5, we are going to simplify. So I'm going to go ahead, simplify the expression. When I look here, I have cosine of x plus pi. So cosine of x plus pi is equivalent to cosine x cosine pi minus sine x sine pi. And what's cosine x? Well, I have no idea. X is an unknown. What's cosine pi? Well, yeah, I know that. It's on my unit circle. -1. Minus sine x. What's sine of pi? Well, I know that. It's right here at 0. So now, what is cosine times -1? Well, it's negative cosine x. And negative, or minus sine x times 0. Well, anything times 0 is 0, so minus 0. And that is going to equal negative cosine of x. There we go. Alright. Take a moment. Do number 6. Pause right now because I'm going to go show this answer. Alright, there is the answer to number 6. And I'm going to have to come back and show number 7 and 8 in the next video because I don't have enough time.